Hello. Good afternoon, Daniel. Good afternoon. And can you hear me or can anybody hear me? Good afternoon, Camilla. Good afternoon. Yes, good. All right, awesome. So, okay, wait, people are coming in and then I'm going to continue. Good. Thank you. I totally appreciate it. That's points right there. Okay, I'm going to start again. All right, let's see. So, not a lot of video going on today. I got to say, the other class 203 shows a lot of video. I'm just saying. But anyway, okay, no. Good afternoon, Daniel. Because you guys already know that I'm a pushover and I won't worry about it. Okay. Good afternoon, Daniel. Good afternoon, Camilla. Good afternoon, Luna. Welcome back. Awesome. I'm glad you. Okay, so that worked. Anyway, yes, Daniel. Oh, right. Got it. Thank you. That counts as points. And thank you, Luna. And thank you, Camilla. Good afternoon, Nikaya. Good afternoon, Darina. This is such a deja vu, such a wonderful deja vu. Did I mention I'm going to give back midterms this year? Okay. Good afternoon, Jerry. Good afternoon, Yoon. Good afternoon, Jennifer. Good afternoon, Ashley. Oh, more people coming. And again, please, if I'm mispronouncing your name, please let me know. Also, please, if I'm making you feel like I know other people and I don't know you, I apologize, and I will get to know you very quickly. And plus, being known by me is not necessarily a good thing. Hold on, more people coming. Okay. Good afternoon, Jenna. Totally appreciate it. Okay. Guys are weak on the video. No, did I say weak? I didn't mean weak, but I do have to say, no, I don't have to say it. All right. Anyway, it's good to see you guys. Okay. We're going to start in a second. Who else? Okay. Okay. Oh, more people coming. Hold on. Okay, hang on. Okay. All right, bear with me one more second. We are about to roll. It is good to see you guys. It's good to be rolling in another semester. I understand, even though I can't see you, I understand that some of you are actually broadcasting this live from John Jay. And congratulations to those of you who are on campus or who are getting there at all, or having any labs on campus or anything. That's good. That's a step in some kind of direction. And I know that must be some drama. Okay, hang on. There's one last thing I want to say, so we're going to get rolling with the homework and all that. Obviously, again, some of you, I still want to get to know some of you, and I want you to get more comfortable with the routine, such as it is, and how the homework works and all that. Mainly today, we're going to be starting to go over homework 1, thing on a spring. And that's for the benefit, whether you have done it and you think you did it well, or you tried it, but you don't think you did it well, or for whatever reason you didn't do it. We're going over it. We're going to start going over it for everybody today. And we're going to talk about how it doesn't matter who you are or where you are. If you get anything from this class and you feel like, oh, I could be doing this homework better, you absolutely can upload a new copy. Talk about that. And if you haven't done it yet, you absolutely still can upload it and should. To that end, let me say quickly, hang on. Now I'm going to say this to, well, it's interesting. Anyway, I'm going to say this again. I apologize in advance, but my basic instinct or my style is, as much as possible, I want to encourage, reward, and reinforce and motivate and incentivize like good practices. And I don't want to shame or punish or call attention to bad practices. So I'm never ever gonna, if you're not here for 15 minutes or something, I don't notice, I don't think about it. If you're not here for a whole class, that's your business, not mine. I hope you get the information from the video, but like, I'm never focused on whoever's not doing what they're supposed to or could be doing or anything like that. But I am, in other words, what I'm getting at is, I just want to take the risk of just publicly recognizing and thanking you, Alyssa. Thank you, Nikaya. Thank you, Zhang. Thank you, Sam. Thank you, Jerry. Thank you, Jennifer. Thank you, Ashley. Thank you, Yorgelis. I'm sorry if I'm not saying that right yet, or Yorgelis. Thank you, Daniel. Thank you, Camilla. Thank you, Stephanie. Thank you, Jenna. Just saying, I totally recognize that you all did turn in this homework, the thing on the spring, like in time, like before 12:15 today, whether your answers are, and I obviously haven't great, even some of you even turned it in like 2 days ago or something. It's technically due at 12:15 today. So I have not graded it or pretended to grade it or anything like that. Whether you have all wrong answers, whether you only have some answers, thank you for getting it in before 12:15. I just want you to know it's recognized, it's noted. And even if you, when you get it back, even if you don't get all the 20 points, you still have all the time in the world to correct or update whatever reasons I say you didn't get all the 20 points. You're just going to correct that and re-upload, and then you'll get the 20 points. In other words, and those of you who have not done it yet, for whatever reason, you still can upload it, and please do whenever you do. And you still, all of you will just do as many drafts as you need until you get all the 20 points, all of you. If that makes sense. Like every homework is like a first draft. Every homework is like a series of drafts. You're trying to get the first draft in on time for your own sake, for the sake of keeping up with the class. And if you do get it on time, I notice, I appreciate it. That's what I just did. But if you don't get it on, but all subsequent drafts you get in whenever, even if Google Classroom says it's late, that's your biggest, that's it. Google Classroom saying it's late, that's it. And those, the rest of you, and there are like other people that still owe it. The only consequence of that is that I know it and you know it, and that you don't want to fall too far behind. But I will still take the homework happily from everybody, and everybody still has an opportunity to get full credit on this, no matter how many times it takes them to do it, okay? And I just want to keep reinforcing that to everybody, old and new, because we're going to start going over it today, and you're going to start seeing what it is I'm really looking for. And I'm going to be a little bit stricter about certain things than I was in 203. I mean, that's the way it goes. So you're going to find out today, not only like some answers, not a lot, we're not going to finish it today. And I'm warning you of that as well. We're not going to finish it, but whatever we do get through, you'll get a better idea of what I'm looking for. You'll also get a better idea maybe of some answers that you got wrong or something. And all of you, just if you want to, you can go back and resubmit. You can wait till you get the score and then resubmit it, but you certainly can use class to fix your homework. It's not cheating. It's like getting your tuition worth. I just want to make that clear again to everybody. Also, so again, we're going to start going over it soon. It is to help you fix it and to help you see more what to do for exams. Also, we won't finish going over homework 1 today. The class will speed up, get faster and faster as the semester progresses. Right now, we're warming up. We're not going to get through the whole homework assignment today. I guarantee that. Nonetheless, homework 2 is technically due Wednesday, or due Thursday. Like you can still go on and try homework 2 without having talked about it yet, just like you tried homework 1 without me talking about it. But I'll warn you a couple of things, and I want you to do that. Like try to get in some stuff for homework 2 before 12:15 on Thursday. Try to have me notice that you get it in before. But I will warn you right now, homework 2 it's just an unfortunate coincidence that you had all the way to a Tuesday to do homework 1, and you only have to a Thursday to do homework 2. I'm going to recognize right now, homework 2 is a lot longer than homework 1. It's like about sort of math background that you need for this class that we're going to go over. It's math I shouldn't even say background. It's math tools, methods that we need for this class. Some people have them firmly under their belt from other math classes. Some people don't. That is understood. Some people have seen the math material before. Some people haven't. All understood. It is not a diagnostic. It is not a quiz. And it's got sort of 3 big parts. You might be familiar with one, but not familiar with another. It's long. It's worth more points than homework 1. I will tell you right now, it's perfectly fine if you don't finish the whole thing for Thursday. There's no way I'm getting to the whole thing by Thursday. In fact, I'll even tell you right now, the third part of homework 2, is all about vectors. You can totally leave that out for now, to keep yourself sane. There's no way we're getting to the vector business Thursday. You can leave it out. I may not give you the full 20 points until you do everything, but it'll be understood between us. Like, I don't care if you don't get to the vector thing, but just do what you can, but turn in something for Thursday to keep abreast of things. And I'm going to look at I'm going to look at the chat. Sorry. Hold on. Oh yeah, cool. Yeah. Oh, if you've already, so Ashley's point in the chat, if you've already like moved on to homework 2, and then where you got stuck was the last part, you're totally fine. Like, first of all, that's not unusual. it's totally understandable. You're ahead of the game, not behind. I will help definitely with the last part. Also, the last part has to do with skills that we do need for the class, but we don't actually need them right away. So it's also okay. Technically, I will say that that last part, technically, in order to do it, and this is often true, technically, the only information you need in order to do that last part is the definitions provided in the sheet. Like, it's not that I'm expecting you to have all this background research or do all this. Technically, if you just take the definitions that are provided in the sheet seriously, like for what a dot product is and what a cross product is, then that is enough to actually get those answers if you take them seriously and sit and think about them. Of course, if you do anything supplemental, like look in the book or a book or Khan Academy, that will help too. But that last part, I am not assuming that you've all had it in your background. I'm not assuming that. And parts in the beginning, I'm assuming that you do have in your background, but frankly, I'm assuming people are either super rusty or they never really liked it the first time when they got it in their background, or it was presented badly in their background. Like, I'm not assuming that you guys are coming and being experts on that sheet. Homework 2. Homework 2 is provided to show you what we need to get under our belt for this class. It will take us a while, and it's not like interesting, it's just important. Well, it is interesting actually, but so it'll take us a while to get through homework 1 and homework 2. So as long as you hand in something for Thursday, like the first part, just to show that you're trying to keep up, like, you're fine and I'm fine. And whether or not I won't give you all the points right away until we finish it all, but you'll get the points later. No one's being docked points for lateness or for multiple drafts or anything like that. So yeah, if your biggest concern is the last part of homework 2, then you are totally where you need to be. You are not behind by any means. That's Ashley, and then yeah, no, cool. You're fine. Believe me. Excuse me. Also, so we're going to get going in a second, but I want to say that what I do think happened, I should check formally. Maybe I will check. How is it? I do want to say that with the game homework, there's 2 types of homework, right? Again, for people who don't know me, there's sort of 2 types of homework, but each of them is worth points each time. And some are worth more points than others. Some types of homework are easier to do than others, perhaps, but all the points that you get for homework all go into the same big pot. This is what I tried to explain last time. Just so you know, again, every single point that you get on any homework goes into a pile of points that accumulates through the semester. And then at the end of that big pile of points gets scaled down by some universal factor. So like if you have 300 points at the end, it may be divided by 30, or some number that I don't know yet, but will be the same for every single student. It might be like 30. So say you accumulate like 300 points total by the end of the semester between all the homeworks, both types, game and problem sets. Then if you accumulate 300 points, I'm just reminding everybody, just so you see how it works. If you accumulate 300 points and the scaling factor this semester turns out to be 30, so we take your 300 points and 30 would be the same number for every student, but one student might have 300 points in your bucket. Another student might have like 450. Another student might have 120, whatever. Say you have 300. We divide it by 30, that makes 10. That means 10 points are being added on to your exam average to make your final average for the class. 10 is a realistic example, like the typical amount of points that gets added. And I know the people that had me for 203 last semester didn't really get the benefit of seeing all this in action because I got so like haphazard with the Excel sheets and everything by the end. They never really saw them, which again is my bad, but the other classes did, and you will see that a typical person, typically in a semester, will get like 9 to 12 points added to their exam average to make their final grade. Some people will get less, some people will get more, but the scaling factor, this whole system is designed to make it so that there's 2 different roads to an A. Like either you could be a rocking exam kind of person who totally gets a 95 on every exam and a 95 in other labs. And then as far as I'm concerned, if you never do any homework or you never participate in class, that's your choice. That's your business. No problem. You got an A. Similarly, someone who can't get A's on tests, can't get 95s on tests, but has like, if you have 83s on the exams, but you did all this homework and 83 in the lab, and you do all this homework, all this participation and these problem set homework, you could easily get 12 points added to your average and easily have an A, even if you had, an 83 exam average. That's how it works. That's how it works. We're mostly in class, of course, tending to focus on the big, thick, quantitative problem set, like standard physics homework, which is what is the core of the class and what the exams look like. And, you know, the faster we go and the more I get rolling, the more that's all we spend time talking about in class is these problem sets. But at the same time, you've got these game assignments, which are all just your record of class participation. Just to make this clear, I'm going to go back for a second. And they, you know, they're a little confusing at first, I'm sure, to most people, but I think you get used to, hopefully you get used to them fast. Hang on, I'm going to check something right now. Yeah, like with game turn one, every single person that turned that in got it back already. And yes, I want to thank Alyssa, Nikaya, Zhang, Sam, Yoon, Ashley, Yorgelis, Daniel, Darina, Camilla, Stephanie, Jenna. I think that's it. Like, if you turned one in, then you got one back. And I think that means you're pretty clear on what the deal is with that. With those turns, every single class, there is one. There's already a turn two due before midnight tonight. I think you all get the idea. You're just supposed to take a moment to jot down any form of participation you did today, including just saying hello. That counts. As long as you do it before midnight, you get the full 5 points. They are real points. I am doing this thing this semester. I didn't do last semester. I'm going to say, if you don't do it before midnight, if you do it after, like if you do it tomorrow, then you get 4 points instead of 5. I would like that's a little bit strict on my part. And that's, ironically, that means I'm being stricter with these game homeworks than I am the problem set homeworks. But there's a reason, which is that they only take 20 seconds to do. And they're meant to be a moment of self-reflection and accountability to that particular class. So if you start waiting too long to do them and then they start piling up, it starts defeating the purpose and starts becoming inauthentic. So all you got to do to get the full points is like do it on time. And if you weren't in class, or you didn't participate, then don't do it. And then you just don't get those points. And I think you all understand that all the other game things, just again, reviewing for people that don't know me or whatever, anything else that has the word game in it, but it's not like turn one or turn two, anything that's like video game or game avatar or game, those are all just any specialty way that you might have participated. And those are all in addition, like those are, all are due. They don't have to be done at all, but just anytime you participate in any way that any of them mentions, as long as you do it before October 1st, just pop a record of that into the portal. For example, I don't know if I made this clear last time. One example is if you show video at all, even for 5 minutes, just screenshot the fact that you showed video, write that down, put it in the video portal, boom, you get points for that. If you have anything other than a black box ever up, any kind of avatar, could be a picture of you, but it doesn't have to be. Just any picture to distinguish you from the black boxes in Zoom, just to make me know you better, then you just submit a screenshot of that into the avatar, however you say that, portal, you get points for that. One that's a little bit confusing, I think maybe I used it last semester, I think maybe some people know, but the one that's called closing a conversational path, which I think I put in your stream, that means if ever you ask a question at all with your voice or in the chat or whatever, and I answer it, you feel like I answered it, or even if you didn't like the answer, but you feel like I answered it, if you just write in the chat like, thanks, got it, or you answered my question, or you can move on now, or anything, if you just do anything to indicate that our conversation is now like come to a close and I can move on, you can't believe how freaking helpful that is and how human and nice it is to do that. And it doesn't have to be for me, it could be for another student in the class too. But if ever you just acknowledge like, yeah, we connected, I asked, you answered, I'm good. You do that, just screenshot that, put it in the portal for closing a conversational path, and that's points. Just so stop me if I'm bad. I'm speaking fast because I'm saying things that I think you all know, but I'm just trying to reinforce and remind how it works. But it looks like everybody sort of gets the game homework. A bunch of you did it. Thank you. You got it back. If you did the homework one thing on a spring, you'll get that. Technically that was due at 12:15. So today, so I didn't grade them yet, even if you did them early. Sometimes I will, but all right. Let me just check the chat and make sure. I'm going to take a breath. I'm going to start going over ThingOver. Okay. I'm going to start going over. If there's nothing in the chat. We're good. We're good. All right. So I'm going to start. Hang on a second. Okay. hold on. But yeah, please do stop. I feel like it's very quieter today than you all are here, right? You can give me someone, just give me something, just like say hi or so. You can hear me, right? We're good. We're ready to go.
Hello.
We can hear you.
Yeah, we can hear you.
That works. Thank you. All right. Thank you. Okay. Thanks. Everybody who just answered that counts as closing a conversation, by the way. Thank you. You totally get points for that. All right. Thank you. All right. All good. Okay. So we are going to start going over a thing on a spring, the homework one. I guess I kind of did start you off last class already, but remember, at least right now at this stage of the course, what I'm doing on the whiteboard to try to show you my thoughts about like answering the homework, I'm more or less trying to show you an example of what I would want you to give me in the homework. So even if you got these initial answers right, but you didn't like do what I'm at, like, it's not about the right answers. It's about following these processes and these procedures. That's how you get all the points. It's possible to get no right answers and get all the points. It's also possible to get all the right answers and not get all the points in the homework, because it's about following certain procedures. So, all right. So remember, you're doing the homework on a separate piece of paper. You're not doing it on the sheet itself. I might pull up the sheet in a second to remind you where we're at. But you're pulling out a separate piece of paper or a separate document, whatever. But then you're giving me everything I need in that separate document to understand what the problem is. Like, I should be able to follow your physics without consulting a separate sheet, or even better, you should be able to give your homework assignment to somebody who knows physics but doesn't know the homework assignment. You know, Walters, Wu, whatever, some other instructor, some other physicist. You should be able to give your homework to them, and they should be able to grade it. Like, I mean, not literally grade it, but they should be able to follow whether it's right or wrong, whether it's good or bad physics from everything just that you write down. They shouldn't, in other words, it should stand alone as an independent physics product. That's your goal, without any other reference to some homework assignment. Therefore, we're going to start off always with a diagram and the fact pattern, just like I did in the sheet, but you're going to give your version of the diagram and the fact pattern. And then each question you're going to make clear, even concisely, even in abbreviated form, but you're going to make clear what the question is, then start working on it, show process, and then give a final answer to that question and box it. Like, that's what we want to do for all the points, even if our final answer is wrong, right? So on this one, so thing on a spring, and I forgive me, I'm going to start from the beginning again, because even though I sort of did last time, but some new people have joined the class and whatnot. So again, this is like a model of what your homework would look like or should look like, something like this. And please stop me at any time. Now, I don't even actually remember which way the spring goes, but it actually shouldn't really matter. It might have, in the actual thing, maybe someone could tell me in the chat, the spring might have been going the other way in the actual sheet. It doesn't actually matter, but if I'm being confusing by doing this,
It was
going the other way. All right, thank you. All right, so it technically it doesn't matter, but I don't mean to confuse people or be like weird. So, okay, thank you. Okay. And that's total points right there. Was that Nikaya? I wasn't looking up. Who was that?
Yes, it was.
Okay, sorry. Oh. Okay. So now, no, I believe, I mean, Stephanie, tell me again if anything else is wrong in the picture or if any of my numbers are wrong, but I believe this is the setup. Notice, I believe that right here, I'm conveying all the same, like all the vital stats, every piece of information that's going to be important that was in the original sheet, I think I've conveyed right here. Everything we need to do this problem, I think I've conveyed right here. And it captures that info, but I didn't write it exactly here the way I did in the sheet. And that's the point, right? Like neither would you. This is like my own little style right now. I'm showing kind of what I'm doing here is not only giving the reader all the information they need to follow the reading, but also I'm kind of showing that I get what's going on, right? I've just personalized this enough. I didn't just copy and paste from the sheet. I kind of did it my own way, just enough to show Yaverbaum or whatever, like, okay, I got you. Yeah, I get it. It's like a mass on a spring within this, right? I didn't write out all the words. I just wrote enough to show the situation. And then I know what the situation is. And I think this is it. I mean, I might be forgetting something, but, and side note, notice in the diagram, the way I label things with the constants or the variables, like M is the mass, K is the stiffness of the spring, the initial position of the mass, like where it starts. I could even say this, like the place where the mass is held at rest is known as X naught. Then in the fact pattern, then I sort of define those specify those variables with the numerical values. But it's a nice little tradition that I don't put the numerical values in the picture here. I put the letters in the picture and then say the letters have these values. Especially in 204, that's a really important habit. We sort of did this in 203, but it's really important in 204 to really try to think in terms of letters and postpone numbers to the last possible minute in every problem. Like physics 204, it gets pretty mathematical for good or for bad. The math gets pretty heavier than 203 and kind of abstract. But by math, we mean a lot of equations and a lot of calculus and a lot of relations. The particular numbers are just particular values for one experiment, circumstance or another. We really want to be able to think and distinguish between variables, constants, and so forth. So the more you can get used to thinking of letters as the agents of action, and the less you're getting bogged down in numbers, the better habit it is. Right. So anyway, that's the situation. And then question one, I believe, or part one or whatever, question one was something like this and I believe we did this together in class last time, but oh, hold on a second. Okay. I'll ignore that. In fact, wait, bear with me for 1 second because I just got something that I have to deal with also. Okay. So I believe the question is that t equals 0. What's f equal? So notice now. All right. So I'm starting question one. I'm writing the question out in some kind of a way. That's super important. Like whether I know you or not, super important. Before diving in and solving for the answer for question one, I'm making clear what the question is. Maybe if I'm as cool as some of you, maybe I do it even in its own color or something. I'm making clear what the question is so the reader knows what the question is. Okay, I'm going to ignore that. Okay, I think that's the right question, right? So then, even if you can do this in your head, or especially if you can do this in your head, I don't care if you think you instantaneously know the answer, you show out the steps. And I think I did that in the last class, so I apologize for the redundancy, but you do out the steps. The more easy you think something is, the fewer steps you think it took you to do it, the better, the more helpful it is for you to try to drag out what you did into a number of steps. It's not to prove that you didn't cheat. It's not because I don't understand you're really smart and can do these things really fast. It's to train your brain, right? Like the truth of the matter is, even if I know the answer to this one really fast, or even if I already got it from the last class, they're really fast just means that there was a number of steps that my brain zoomed through really fast. There are steps. And the whole idea is to slow down the steps and write them out so I can see what steps my brain does when it knows something. because we're going to quickly get to the point where we don't know the answer or we don't know what to do. So we need a model, we need a movie of steps to show us what to do when we don't have the answer already in mind. The only place we could possibly get that model is from things that we do know how to do. So the more easy you think something is, the more I recommend and request and demand that you drag it out and see, why was it so easy? What was it that you were doing? So here, for example, again, because I know we did this already, but here I'm asking for force. So instead of just like diving in and writing like 300 or whatever the answer is, what I do first always is I write down some general truth about force, a definition ideally, or a fundamental law about force. I'm going to, in this case, like I write down, well, in general, F equals negative KX, right? Because again, even if you think you did this in your mind really fast, this is what you must have done. You know that in general for a spring, F equals negative KX. And then you said, okay, fine. So I'm just going to continue on the, well, yeah. And then you said, well, in this case, the K is 200 newtons per meter. And the X at this point is 0.15 meters. So in this case, F equals negative 30 newtons. And again, I know we got this answer already last time, or at least I think we did. And then you make a big freaking production, like maybe even make a bigger production of the fact that this is your answer. And notice it has units in it, it has a negative sign in it, right? That's, and correct me if I'm wrong, again, maybe I'm flying off on some weird, but I believe that's the answer. Okay. But I'm telling you, as long as you, and granted, even this was only 3 steps, but that's 3 steps more than some people were thinking. If you just wrote that down, I'm not giving full credit. It's conversely, if you wrote these kind of steps out, but then still happened to like do the math wrong or something, at least on homework, I'll still give you full credit as long as you show me this process. One, and stop me again. I mean, that is the answer. Hold on, I'm just erasing the chat, or not erasing, but one thing I'm going to tell you right now, if and when you get your homework back, well, actually, I'll write on the next page. A common thing that I write, maybe I told you this last semester, I actually don't remember, but a common thing that I write, and I'll write it on exams too, is if you see this, if you see WIQ, if I write WIQ and I take off a point or something, it means this. It means I need to see the question first, even if you think it's obvious, even if you think it's obvious to me. It's super important that you, especially the less you understand, the more you get to things where you don't think you can solve the question that easily, where you're confused by it, actually trying to put down the question and translate it is a hugely important step in breaking through the wall. So anyway, if I ever write WIQ, that means what is the question? In fact, I'll give you the other things right now. Some of you know, if I write, if I write www, it basically means why, what, where, from. It means show a lot more work. I generally write that when people write down equations that I know they got from the web, even if they're correct equations. If I know the person is just writing something down that they have no idea where it came from or how it applies or how it breaks down, I'll write www. And what's the other big one that I tend to write when I'm saying, there's another one, but I can't even remember now. Oh yeah. and I'm not trying to be like a kindergarten teacher about this, but if I write like PCA and circle the C or something, that means please circle the answer. And as silly as that sounds, and it does sound silly, it shows you the fact that I'm making a big point of this right now. Like those three things, WIQ, WWW, PCA, if you really think about it, it's like WIQ is start, PCA is end, and WWW is all the stuff in the middle. Like what I'm really trying to show here and what we're trying to nail down is process of thinking through things. What we're really all about here is what to do. What we're all about here is knowing what to do when you don't know what to do. The assumption here is that the questions we're going over right now are not that bad, but pretty quickly we get to questions, even like question number 9, where it's really easy for people to look and go, I have no idea what to do. And what I'm trying to say here is no, even when you think you have no idea what to do, you totally have an idea what to do. When successful science students at this stage of their career say, I have no idea what to do, what they generally actually mean, well, is a number of things. One of which is, I can't quite see the final answer yet in my mind. And I'm like really smart and I work really hard and I'm used to being really successful. So I'm used to I'm used to having a ton of work. So I'm used to being able to navigate through all my work. So I'm used to being able to look at questions and like know what to do right away. And it's just a matter of sweating blood and doing it. I'm used to looking at things and knowing right away what to do, i.e. kind of envisioning what the final answer is going to be, more or less. And I just have to slog through. So when they say I have no idea what to do in physics, what they really mean is like, wait, I don't actually see how this is all going to turn out. And I'm saying, right, welcome to the real world of scientific research. You don't know how it's all going to turn out, but there's ways to start nonetheless, and there's ways to find out while you're going. And one of them is to write down the question for real and translate it. Another is to then move to definitions to define the terms in the question, then start plugging in values to those definitions. And then when you get to an answer that actually answers that question, make it clear that that's what you've done. Like those are, and it's kind of just the middle part that people sometimes flail around. So anyway, these are the 3 things to look out for. What is the question? Where are you getting your steps from? And usually, again, it goes start with definitions and general laws and work your way down to the particular. Go from the general to the particular. People always want to go the other way, but the real way to do it is that way. Go from the general, from the big to the small. And then when you get to the end, circle your answer for your sake and mine. But okay, that's like a sidebar. All right, but we've done question 1. Let's move on to question 2. Stop me if I'm starting to talk too fast. It's 1:30. Okay. And I hope the answer I just got for question 1 was the same as I got when I started you off last week. But all right, we're now going to go to question 2. And feel free to chime in also. I mean, if you think you have an answer or something. But so I believe question 2 on the sheet was at t equals 0, what is the acceleration, I believe, i.e. at that moment t equals 0, what's the acceleration? And again, stop me if I'm wrong, because notice I'm not looking at the sheet. That could be a problem. But what we want here is an instantaneous acceleration. It's not average acceleration. It's not a with a bar over it. We'll even say, like it's acceleration at that moment. My assumption is, or my background assumption, looking at this whole situation, is the acceleration is probably, going to change every moment. So it's not just like, I'm not going to use a equals v minus v naught over t, for example. It's not average acceleration. It's acceleration at that moment. But how do I get it? Well, so that's the question, right? So I'm going to show work now. Maybe I'll change color. Show work. I'm going to go, I did, well, I'm going to say this, general principle. Right? This is Newton's second law. It was true in physics 1 in classical mechanics. It remains true throughout this whole course. It's still a very fundamental law. Okay, just reminding you, F net equals ma is a vector equation. It means if you add up all the forces acting on an object, acting in a particular axis in a particular direction, then that will produce the acceleration instantaneously along that given axis, right? I mean, in other words, really, F net equals ma is really three independent but simultaneous equations. It really means F net x equals max at the same time as F net y equals may at the same time as F net z equals maz, right? It's true independently along three axes. But if we look at the axis that we have here, the x-axis where all the action is, there's only one force acting here. We just figured it out. It's the spring force, right? So in other words, right? There's only one force. It is that negative kx force for which we just got a number, but I'm trying to postpone numbers as long as possible. So I'm going to say, and stop me if you want me to go back to this sheet. I mean, I'm turning the page, but please do stop me if you want me to go back. But I'm saying here, right, or even that. Now I'm dragging this out again. I'm not saying you have to drag it out quite this much, but notice I'm trying to keep it as general as I can, and solve for the thing I'm trying to solve for, but with putting numbers in at the last possible minute. I'm looking for A. All right, now I can put in the numbers. I could put the K and the X back in again, but I did just get, in the last part we got that it was 30. And the mass is 0.3 kilograms. So the acceleration is negative. Right. So that's my, I'm not crossing out, it's a highlight, I guess, but that's my answer for number 2. It is negative. It doesn't, it means the thing is slowing down in this case. Sorry, no, it doesn't. It means that it's accelerating in the negative direction, which, I should actually, one thing in my diagram, I'm sorry, just to make it totally clear. Here's my diagram. One thing I should have put in my diagram, you should put in your diagram, my bad. I should have made it clear. This is always a good idea. And I'm sorry, I didn't. I should make it clear in this diagram that we're calling that direction positive and we're calling this direction negative. We could have made an opposite choice. We can make whatever choice we want, but we should make a choice at the beginning and then stick with that choice. So assuming that to the right is positive, because the problem said that where the mass began was at positive 0.15 meters. So assuming everything to the right is positive, then everything to the left is negative, right? And so if we're getting that the acceleration is negative 100 meters per second squared, that just means that the thing is accelerating toward the equilibrium position. While it moves that way, it is speeding up, for whatever that's worth. Like just like the force is negative, meaning that the force is pulling it to the left. Negative means to the left in this case. I don't know if that's clear or confusing, but that's my answer for number 2. I'm just going to pause for a second, but I think that's the correct answer, but it does have a negative sign in it. It certainly has to have the same sign as the answer for question 1. Okay, are we good so far? I'm just checking. Are we good? Oh, yes, absolutely. Thank you. This page or the page? Wait, this page? Or the one? I'm actually, no, the other one. Okay. This one? Wait. Okay, cool. By the way, I'm totally going to open up a portal for that. I just haven't yet. I'm going to open up a portal for anybody who asks me to go back a page, because it does take a little guts to do that, but it totally just shows that you're paying attention. Like, it makes me feel like I'm teaching more. I know people actually are taking notes or pay. So thank you for asking. And yeah, okay. So let me know. And yes, people should be taking notes. That is a good thing, or at least trying to follow. Okay, so I'm going to pause for a second. Awesome. Thank you. That counts as closing a conversational path as well. She just got like 59,000 points just for like that. All right, cool. Thank you. All right, so I'm going to go. So that was that page, and this is that page. All right. So now I'm going to go to question 3.
Professor, I have a question.
Oh, yes, please. Yes, yes.
What if you didn't specify in your diagram which direction was negative or positive, and then you put like A is equal A, the mass accelerated 100 ms squared to the left or something? Is that still correct?
Oh, yeah. If you said to the left, that's great. In some ways, that's even better. If you in any way indicated a knowledge of direction, that's great. And yeah, that's totally great. And as long as we both understand that it's accelerating in the same direction as the force, like what would be weird is if the force did have a negative sign and the acceleration didn't or something like that. But if you say to the left, totally fine. Yeah. Yeah.
Okay. Thank
Cool.
you.
Thank you. Good question. All right. That was 1,000,000 points right there too. Okay, awesome. So that's that. Oh, and also to everybody, I'm just trying to give you the ideal optimum here. Like I won't necessarily, I mean, you'll get away with stuff in your homework and I won't necessarily get all, I mean, this is just like the ideal, but yeah, okay, we understand each other. All right, so that's question 2. So question 3, question 3 is now I believe it is, and tell me if I'm wrong, but now we shift. Like the first 2 questions were about what's going on right at that first moment when we first start paying attention, when the mass was at rest and released, right? So at what we're ultimately going to, at the initial position is what those first 2 questions were about. Then the next question is about, all right, now let's assume it was released and it starts moving in at this initial rate of acceleration, like it's being pulled in by that force of the spring. It's accelerating in due to that force. So it's going to start moving in and eventually it's going to get to the it's going to get to the equilibrium position, which by definition is known as x equals 0. Like all these x's are being measured from or in comparison to the equilibrium position. So I believe that what we're asked now is at when x equals 0, we're asked, I believe this is a question, please correct me if I'm wrong, but I believe we're now asked what's the acceleration at that moment. And the assumption there is that the acceleration is not remaining constant. We're now in physics 204 land now. Like the acceleration apparently is changing at every moment because the acceleration is based on the force and the force is based on the position x, and the position is changing every moment. So now, again, you might even just see it in your head right away, and you may well be right. But just to be clear, like, again, the way we get this is, well, I'm dragging it out. You don't, very few of you will have all of these steps in your homework. I recognize that, but I'm just trying to be as thorough as possible. But here now, so this whole thing is now, and again, I know you can see that in your head, many of you. But I'm not just asking to put you through torture. I'm also asking because it's actually an important, like many of these questions are meant to point out something and give you knowledge that you need for the rest of the sheet or for the rest of life. Like notice this thing is zooming in, like from the moment we release it, it's being pulled in, it's coming in, it's accelerating. But notice its acceleration is going down. That's a little bit interesting. It's going to get more interesting as we go. Like it's accelerating, which sounds to people like speeding up. And in fact, we're going to find out it is speeding up, but the rate at which it's speeding up is going down. That's a little bit like do you want to think about that for a minute? The acceleration is going down from 100 meters per second squared. And granted, there's a negative sign there, but now this goes to Nikaya's point. When we said negative, that just meant to the left. So for the moment, don't even think about the negative. If you just want to like picture the situation, the thing had this high rate of acceleration right at the beginning, but its rate of acceleration is decreasing until it gets to the center and it has no acceleration at all because it's not being pulled at all, at least at that moment. Daniel, I mean, I see something in the chat. Hold on. Yeah, right. And what I'm just saying is, look, I'm not saying when I see your homework, I may or may not get all vindictive. Like I might let it go, but I'm just telling you optimally, ideally, show work for all of these. Some of these, even when I say show work, it might just be 2 lines, but at the very least, what I want you all to distinguish between is triple equal signs and double equal signs. Like the reason the acceleration is 0 is not because it's always 0. It's 0 at that moment because acceleration is always net force over mass. Like you know what I'm saying? Every question we ever ask about a particular circumstance, your brain at least has to go through 2 steps. First, what's the general principle? And second, how does the general principle apply to the particular circumstance? You want to get in the habit of distinguishing those. Like you think that in your brain, you just did it right away, and you did. I mean, I know you guys did. Like you just saw like, duh, it's 0. But think about when you say duh, it's 0, it's because in your brain, you're plugging in 0 for X, already knowing that A has to equal like something like X over M. Like you did, you're very smart, but because you're so smart, you did a bunch of steps really fast in your brain. Don't insult yourself by thinking that because you did those steps so fast, that means that they weren't steps. That literally is insulting yourself. That's like thinking just because you did something fast, there must not have been anything that you did. You know, so you're trying to take the movie of your brain and slow it down and look at all the frames clearly so that you've got a movie to look at when you don't have the ability to do things so fast. I'm not saying I'm definitely going to, I don't know if I'll take off the points this time or not. But by the way, if I did, then just redo it and rehand it in and you'll get the points back. Oh, that's a good question. Oh, no problem. She just closed the conversational. That's good. And I want to answer Stephanie's question. That's a good question. That's a very fair question. I'm getting a little technical when I put in the arrows. When I put in the arrows, I'm making it clear that it's a vector equation. Truth is, I could even put those arrows. Oops, sorry. If I want to be that technical, I even could put them in this equation too. It's being a little picky that I put in the arrows. So, and I'm doing it partly to train you because you're going to need to focus on those arrows a little bit later in the course. But that's me being picky. If you don't put the arrows in, that I don't think I would. It's not so. Here, this whole problem is one-dimensional. So the arrows don't really matter. So I mean, if it were a 3-dimensional problem, then we would start really caring. I won't care if you don't put the arrows in here. That is me being overly technical. But I will say this. On Stephanie's question, which is a great question. Don't overstress the arrows, but do notice, everybody, there's a big difference between I wrote F equal, and this is on purpose, and I'm doing this in a certain order every time. Notice I wrote sigma F equals MA, and then I wrote just F equals negative KX. That's an important distinction. When you write Newton's second law, I don't care if you put the arrows in. But don't just write F equals MA. That would be wrong. Either write sigma F equals MA or write F, like you could write like this, F net equals MA. That's fine too. But somehow you want to make it clear that Newton's second law says add up all of the forces together on a given axis, and that produces the acceleration. That's what Newton's second law says the sum of all of the forces on an object together produces the acceleration. And then we have particular laws that tell us how particular forces work, like Hooke's law says the particular force of a spring is negative kx, or like from physics 203, maybe like force of friction equals mu times the normal or something, or force of gravity equals mg. Like I definitely do want to see a distinction between the law that tells you how forces work in general versus how any one particular force works. So again, Stephanie's question, totally good. You don't have to get bogged down in the arrows right now, but please, whenever you write Newton's second law, don't think it's just force equals mass times acceleration. It's the sum of the forces equals mass times acceleration. Okay. Oh, cool. Cool. That closed the, Stephanie just got closing the conversation points. Awesome. Okay. That's good. All right. I'm glad we're good. Okay. I'm going to, last thing to everybody again, and I really mean this. I really mean it. I mean, what I'm about to say, I mean, the point of homework is it's all drafts. Everybody has the opportunity to ultimately get all the points on all the homeworks if they have time and if they have interest. You could, like 2 weeks from now, even if you get a 12 back on this homework one that was worth 20 points, you could just keep churning it until you get to 20 points, like for weeks from now. Just don't fall behind on the other ones or whatever. But everybody can get all the points eventually if they eventually do everything they're supposed to, even if you got all the information from class. That is fine. But one thing I want to make clear is if you like do the homework once and you got a 17 on it, and that because I said no, you didn't show your work here on page 3 or something, then don't just upload page 3 like the next time. Please don't ever upload fragments. If you did everything perfect on page 1 and 2, and I said there's things missing on page 3, fix the things on page 3, but then reattach it to page, then insert it back with pages 1 and 2 and re-upload the whole thing, please. Again, the standard, it sounds like I'm being super picky about weird things. I am. And I'm super unpicky about other things. It's hard to predict. That's why I'm saying it over and over again. But what I'm picky about is every one of your homework assignments, you want me to just to take the document and have it exist on its own. You don't, as though it's an article that you're trying to submit to a journal for publication. Honestly, that's what this is all about, really. So if you do an almost perfect homework and have one little flaw in it and then want to get all the perfect points, just fix that flaw, but then just give me the whole homework all over again, please. So that I can look at it and see, oh, this is a perfect homework now. They get 20 points, right? Okay. And that shouldn't cause you more trouble as long as you know that. But all right, so that's question 3. Let me see what time it is. Yeah, that's question 3. Now we move on to question 4. So now I believe question 4 is, now it gets interesting. Stop me if I'm wrong, but now suddenly things shift because I believe question 4 is at x equals 0, what's v? Am I right? Can someone confirm? I believe this question is, what's the instantaneous speed at the moment the block reaches the equilibrium position? Can anybody correct? Thank you. Awesome. That is points right there for Camilla, ladies and gentlemen. Or else I like the way she said correct too. It's cool. Okay. So yeah. So now we're saying at x equals 0, v equals. Okay. This is a harder question now, or certainly this question now takes things in a different direction. First thing I want to say is, and stop me if the question is not clear. Like in English, right? I'm saying we let the thing go. It's moving in, it's being pulled in by a spring. The spring mathematically, a spring is like a string, only a spring pulls in this interesting way where the pull is directly proportional to displacement from equilibrium. That's literally the definition of springiness or of elasticity. Elasticity means a restoring force that is directly proportional to displacement. In engineering, they sometimes say the stress is proportional to the strain. That's the same idea that we're saying here. So this spring is pulling this block in. It was at rest. We let go of it. It's pulling it in, and the mass is starting to fly in toward the equilibrium position. And it's going to get to the equilibrium position. But now we're asking, how fast is it moving when it gets there? First of all, that very question assumes, it sort of makes it apparent that we don't believe the answer is 0. And I don't. There's no reason to assume that this thing is trying to get to equilibrium, but that doesn't mean it's just going to stop on a dime when it gets there. It's not a cartoon. Just it was accelerating, you'll recall. We just figured out an acceleration in the last 2 questions. So it's getting faster and faster, and it started at 0. So it's building up speed. It's going to have a lot of speed when it gets to the equilibrium, i.e., I think it's going to keep going past the equilibrium. It's going to start compressing the spring on the other side, if you're picturing this the way I am. So we're looking for instantaneous speed at that particular position. So the first thing I'm noticing is Note 2, kind of like we said above in question 1 or whatever, instantaneous velocity is not the same thing as average velocity. Not the same thing. I'm not going to do displacement over time here. First, the truth is I don't even know the time anyway. That yeah, I don't know how much time it's going to take it to get to the equilibrium position. So like that wouldn't really help me anyway. But this is not a displacement over time kind of situation. We're not asking about on average how fast is it going from here to there. We're asking how fast is it going right now at equilibrium. So this is a different kind of question. Also, by the way, if you don't know me, I'm using a symbol that maybe I haven't defined in this class. This is like a sidebar. You might already know this from another class, or you might know this from me last semester, but just to be clear, in case it's not clear already, for in physics and in other areas of science, we use double equal sign to mean sort of traditional equals. If you find out that two things are equal, because you noticed it in the lab that they're equal, or you come to a conclusion, you come to a general induction that two things are equal, we use a regular double equal sign. But if two things are equal because they're defined to be equal, like average velocity is equal to displacement over time, not because we ever discovered that in the lab, but because average velocity is just the word we use to substitute in for the longer set of words, displacement divided by time. Like we defined average velocity to mean displacement over time. Whenever two things are equal that way, if they're equal by definition, we use the triple equal sign, because that's a very different type of equal. Because if two things are equal by definition, that means the equality was not discovered in the lab. Therefore, it can never be undiscovered in the lab. It means we're never going to find out that we were wrong because we didn't in the first place find out that we were right. We just said that we were right. It's a definition, right? You're never going to, and therefore, if it's true at all, if a definition is true at all, ever, then it's always firmly, rigidly true. A triple equal sign is a much stronger kind of equality than a double equal sign. And ultimately, we love them for that reason. So when I say like V triple equal sign slash V bar, I'm saying by definition, like I'm saying the two numbers could turn out to be the same. Like sometimes the average velocity is the instantaneous velocity numerically, but they do not mean the same thing. Right here in this question, we are being asked for what is the instantaneous velocity at the equilibrium position. Okay, that's what we're being asked for here. So now I'm going back to the question. Okay. Just in case it's not already clear, what we found in question 1 and 2 is that at 2 different points in this situation, the acceleration was 2 different values. The acceleration was initially 0. The acceleration was initially negative 100, and then it was 0. So the acceleration is not constant. Therefore, we cannot use any of our good old-fashioned physics 203 constant acceleration questions. It's not constant acceleration. There is no one value for A that we could plug into anything to solve for V, even though we seem to know X and we seem to know V naught, right? So we can't do this in a kinematics way. We're going to have to, and maybe I even did tell you this. I think I told you this last week, but this signals right away, the minute we're looking at whenever we have a situation like this, whenever acceleration is not constant, wait, sorry. Okay, I'm going to say right now, I might have said this last class, but I'm going to say now we have to shift. Like we were thinking about forces and accelerations. We were thinking about F net equals ma. We were thinking about accelerations, and maybe in our mind we were thinking things like a equals v minus v naught over t, or x equals 1 f a t squared plus v naught t. Like for the first couple of questions, we were thinking in terms of good old instantaneous accelerations and forces. But what we recognized was that the force and therefore the acceleration were changing continuously from place to place. The force was changing continuously from place to place. Whenever that happens, whenever force is changing from place to place, and we can't use our constant acceleration equations, but we are wanting to make predictions about speed, velocity. If you know the instantaneous speed here, but you want to know the speed there, and you know that the force is changing from space to space, that is a strong, strong indication, that is a strong suggestion that the thing to think of now, instead of just forces and accelerations, is energy and energy conservation. The question to ask ourselves, whenever this happens, whenever this comes up in physics, when the force is changing, so when you want to know how velocity is changing from place to place, but you can't just use acceleration because the acceleration is changing as well, the question to ask yourself is the force conservative?
Si tú te vas a ir conmigo, no te vesiste, cabrón.
Lisa.
¿No es verdad? No, no por ahí.
You got a little cut off here. I'm gonna have to explain. Oh, you can't read that. Hold on a second. Okay, I'm going to explain this. You first of all, you can't even read it, but well, let me read it first. Let me see what time it is. Oh, we have like 4 minutes. Okay, then this is perfect. Well, we're going to pick up on this on Wednesday. Just keep going. You're going to turn in a game assignment tonight before midnight for participation for today. You're going to start working on the homework too and hand in whatever you can hand in for Thursday. It doesn't have to be all of it, but we're going to keep. And if you have revisions or uploads or you want to fix this, you can do that now, or you can do it later. But I'm gonna pick up right from here on Thursday. I'm just gonna like say a word or two more about this right now. But this is where I'll probably give you one. Yeah, I'm gonna maybe write one more thing down, maybe. But let me read this first. This says we must ask ourselves. So this is what we always do when you're looking for a speed change from place to place. You know the speed at one place. You want to know the speed at another place, as in point of space, as opposed to point in time, I might add. But if you know the speed at one point in, because we don't know anything about time, notice in this problem so far, we don't know anything about time. Everything is about space, right? It's like where the mass is. So if you have a situation like that, where you're tracking something through space, and you know the speed over here, and you want to know the speed over there, your first instinct might be, well, let me use acceleration. Like that would be my first instinct too. But the minute you realize, oh, I can't use acceleration because it's changing, because the force is changing, then the next question you ask yourself is, oh, crap. You say, oh, oops, sorry. You say, oh, the force is changing. Am I like totally out of luck? The next question to ask yourself is the force conservative? And the answer here today is going to be yes. I have to explain why. But the reason it matters is if the force is conservative, that's going to mean that it conserves energy. So you can, instead of using forces and accelerations, you're going to use energy to solve the problem. Let me just see what time. Yeah, but I'm going to leave it. So you always ask yourself, is the force conservative? Now I'm telling you as a fact right now, with 2 minutes left, the spring force, which is the only force that's doing work in this problem, the spring force is conservative. I'm not saying you knew that or not. I'm telling you this, and you may not know what that means yet. That's my next step to explain to you. But because we're starting now to get into the sheet, the part of the sheet where it may not be review anymore, it may all be new information. It's fine. The spring force always is a conservative force. In fact, this is the last thing I'm going to say. From now on, spring force and the gravitational force are two examples of conservative forces. All other forces you could ever think of from Physics 203 are not conservative. Like friction is not a conservative force. Tension in a string is not a conservative force. The normal force, not a conservative force. Gravity and spring forces are conservative. In short, well, I'm going to get into this on Thursday, but what I mean in English is that they are forces that do a net amount of zero work around any round trip. Like if you throw something up, gravity brings it back down. You stretch a spring this way, the spring brings it back to equilibrium. I mean, basically, it means that there are forces that have equilibrium associated with it. But I will continue from that point on Thursday. That's all I'm going to say right now. Just keep doing what you can. You are doing great. So you can go. I'm going to stay here for a couple of minutes more, just in case there are questions or you need to copy something down. So I'm not going anywhere, but you're good. Thank you very much, all of you. I will post the recording and I'll post the notes and all that, but have a very nice day, all of you, but I will go when the last person. So bye. Yes, thank you. Oh,
Thank you, Professor. Have a good day.
very much. Thank you. Oh, that's so many points. That's awesome. Thank you. Bye. Have a nice day, you guys. Thank you. I'm going to stop the recording. Have a good day. Have a good day. Thank you very much. Have a good day. Awesome. You guys are good. Awesome. Thank you. Thank you. Awesome. And you good, Yoon, or you good?